Hey guys, and welcome to our video lesson on just getting started adding and subtracting rational expressions with different denominators. So today in class, we started adding rational expressions that had the same denominator, which is super simple because we could just add or subtract the numerators and then put them all over the same denominator since they were already in common. However, when that is not true, we have to utilize multiplication to be able to make the denominators the same, much like we practice with just plain old fractions. Okay, so first of all, I'm going to read this paragraph, which is just what I was talking about. When we encounter rational expressions that have unlike denominators, we need to utilize multiplication to rewrite the expressions to have the same denominator. To do this, we find the least common denominator, which is also known as the LCD, which is the least common multiple, which is also known as the LCM of both denominators. So here are some steps to finding the least common multiple, and we're going to do a couple examples of just doing that. But I feel like once we do the actual addition, it'll make a little more sense why we are doing what we are doing. Okay, so finding a least common multiple. To find the least common multiple of expressions, we follow the steps below. First, we factor the polynomial completely. Now, when I say completely, I mean completely, meaning if I have numbers that can be factored down, I'm going to do that. So I'm going to put that on here. Numbers 2. So for instance, if I had this is just a simple case, like 4x squared, factoring that completely would be 2 times x times x. So I'm just literally breaking it all the way down as far as I can go to what is being multiplied together that's giving me 4x squared. Okay. Step 2, after I've factored all expressions completely, the LCM is the product of the highest power of each factor that appears in either polynomial. So basically, I think this little italics paragraph makes a little more sense. We need to see the LCM include all factors we see in both expressions. However, if the expressions have a common factor, we do not need to write it more often than it appears in either expression. So basically, we're going to make this LCM, and it's going to include all the factors we see in both expressions, but we don't necessarily need to double dip if they have things in common. All right, so let's look at this. Find the least common multiple of the given expressions. So step 1 is to factor completely. I'm going to start with 4x squared minus 16. The first thing I always do in factoring is I look for a GCF, and I know I can take a 4 out of both those terms. Well, that leaves me with 4 times x squared minus 4. Now, I also know that 4 is 2 times 2, and x squared minus 4 is a difference of squares with factors to x plus 2 times x minus 2. Now looking at our trinomial 6x squared minus 24x plus 24, a GCF in this one would be 6, so I can take a 6 out front. And then that leaves me with x squared minus 4x plus 4. And then I know 6 is 2 times 3. And this trinomial is a perfect square trinomial. It factors to x minus 2 times x minus 2, which you can leave like that, or you could write it as 2 times 3 times x minus 2 quantity squared. So either way, it's kind of nice to leave like this so you can see exactly what is in the denominator when we get to denominators. Okay, so when we do the LCM, first of all, I need to include everything I see in both this expression and this expression. Or if you're looking at that, that's fine. So what I see over here is I have 2 2's. Okay, well, this expression has a 2 as well. So I don't need to write that one twice, but I do need to have these 2 2's there. Okay. Now on the left, I have an x plus 2. There is not one of those on the right, so I still need to write that. But I also have an x minus 2. On the right, there are 2 of those. So I do need to write that, but I do need to put the squared on it so that I'm accounting for those 2. And then the one thing I haven't accounted for, so I've done this, I have not accounted for this 3 here, so I need that out there too. So I'll just go ahead and throw that in front. So let me just show you. I'm going to cross out everything I see and make sure that I've crossed out everything in both denominators. So I have a 3. Okay, what color do I want to use? I'll just use red. 3. That would cross off this. Okay, or this, whichever one you're looking at. Okay. Then I have 2 2s. So I have 2 2s over here and I have a 2 over here. So that would cancel that as well. Then I have x plus 2. There's x plus 2. And then I have x minus 2 quantity squared. So that would cross out any x minus 2 and it would also cross out the pair. Okay, so I have included everything that's in both expressions. And now I would simply multiply these numbers because we don't want to leave it like that. That would just be 12 times x plus 2 times x minus 2 quantity squared. And this would be the least common multiple of those two expressions. That one was a little more involved than the next one. This one will go much more quickly. So we completely factor both expressions. Letter B, I have 5x minus 15. I can factor out a 5. That leaves me with x minus 3. And then I have x squared plus 5x minus 24, which is a trinomial that factors to x plus 8 times x minus 3. I'm going to look at the left expression first. There's a 5, and there's an x minus 3. Because there's an x minus 3 there, I've already covered that x minus 3 and that 5. And all I have left to cover is this x plus 8. And that would be the LCM. All right, guys, I'm going to do a different video for the next part.